Good morning, ladies and gentlemen. Today, a Saturday at 11 a.m., 22nd July 2023, we are talking about lightning protection for structure. This is a part 2 series. Earlier, we had lightning protection for outdoor. As you are aware, this is a series of webinar we have been doing since many years, and this is all educational program that we have been doing. And today's webinar is presented by National Federation of Engineers for Electrical Safety. What is NFE? Vision is to make every electrical installation free of accident, such as electrocution and fire due to short circuit, and increasing the reliability of the electrical installation, thus contributing to the saving of lives and properties and supporting sustainable development of the nation. The mission is we shall strive to achieve our vision through getting accredited for products and personal certification. We have already started with AHPA, which is a healthcare association. So we are going to certify electrical engineer to audit hospitals. So we have already within 4 months. So we are now starting the accreditation certification for engineers. And also we'll focus on electrical safety by design, manufacturing, installation, and maintenance of electrical product, and installation by competent and qualified manpower using quality resources, which means NFE we're going to have different type of courses for electrical contractor or electrical installation contractor. So this is a vision and mission of NFE. I appeal to the members who are now present here to join NFE. If you become an NFE, you will get a certificate online with your ID and name on the certificate, and you will be able to access to the huge resources that is there in NFE, and also attend free webinars, free seminars to the members. We have individual membership, we have for companies, we have corporate membership, we have institutional membership, and also student membership. So we have already mentioned you. Please log into our website, and it's online. Within 2 minutes, you can become a member. It's simple process to become a member. We already have, within 5 months, we are almost touching 1,000 members in this country. We have over 30,000 electrical contractors. Our objective is to reach out to all these people and make a difference. Our upcoming events of NFE in association with Bureau of Indian Standard. So we jointly doing seminar on National Electrical Code of India 2023. The next seminar will be held in Pune. It's a one-day seminar. Mr. Gopal Kumar, Mr. Krish will be taking, and Mr. Apau will be doing this as the speakers. So 4th August in Pune, 18th August in Bhubaneswar with the support of local government. And in Mumbai, we probably going to launch our first chapter. Later, we're moving into Coimbatore and Gurgaon, supported by Haryana government. So these are our upcoming physical events. And we will be continuing with our webinars in most of the Saturdays. Next Saturday, we're talking about responsibility of DISCOM. So my colleague Lakshmi and Navya will be putting up those information in the chat box. So today our title is Importance of Lightning Protection, IEC 62305. And my name is Dominic. I've been the host in most of the events and programs. It's my privilege to present to you this topic. So IEC standard is an internationally recognized guidelines that deals with protection of structure and their occupants against the damaging effect of lightning. It provides a systematic approach to assess the risk of lightning strikes and outline effective measures to mitigate these risks. So we may cover up following on a topic like dangers of lightning strike, real life case studies, and we will make this program more interactive. We will love to hear from you, and there is a Q&A box down which you can post your question answer. And those who would wish to speak to the speaker, who is Mr. Gopakumar, please raise your hand. Once if you are raising the hand, I would request you to be there and we'll unmute during this question answer. And all the question answers should be pertaining to today's topic, which is lightning protection as per IEC 62305. Do not post any questions that is not relevant to today's topic. This is my humble submission. Okay, let's move on. We would like to introduce Mr. Gopakumar, who was an evangelist of electrical safety. He has been traveling across the globe and has been quite active in almost all the committees across the globe. He is the managing director and chairman of Cape Electric Private Limited, Cape Electric Power Production Private Limited, and OBO Betterman India, LP Consultant International Private Limited. He is a member of ETD 20, ETD 30, ETD 50, and also an important role is playing with National Building Code 2016. So electrical committee, and we are now in the process of releasing 2025, which is playing an active role in the committee. He's also the member of IEC International Electrical Code, IEC 64, TC 64, TC 81, AC 37. So I would now welcome Mr. Gopakumar to begin this session of today. And once again, I'm telling you, if you're posting the question answer, please be specific to today's topic. And I request people to not to post question in the chat box. Please post only in Q&A, because chat box we cannot record your question because sometime we may not have enough time to reply to you. So we take up from the Q&A and reply to you. So please put your questions only in Q&A box. Over to you, sir.
Thank you very much, Mr. Dominic. So first, let me share the screen. Sometime I'm actually connecting to a new system. It is asking quit and reopen. 1 second, I will quit and reopen.
We had a very good response today. We are over 1,300 engineers have logged in today. We had almost 2,000 registration, and I'm very happy to share. So we have over 1,000 members attending this session. Yes, sir. You're there.
Yeah, because this was asking some question I never expected. So now let me start the presentation. I hope the screen is visible to you.
No, visible, but it's saying launch meeting. So not the PPT.
Yeah.
Yes.
Now?
Yes.
Okay. Yeah. Thank you.
Okay. Go ahead, sir.
Sorry for the small trouble, because last time in the programs, my laptop was creating a lot of trouble. It was taking so much time to open up. So I bought a new laptop, and this is asking so many questions. Security. Okay. Now, good morning, participants. As usual, we have, I think today also we will touch nearly 200 participants. Today's subject is about lightning protection. So I will be talking more from IEC 62305 and National Building Code of India 2016. So today's subject is specific to protection of structures. So first of all, we should understand that the 62305, ISIC 62305, it's actually, even though we call it as a standard, it's actually classified as a code of practice. So according to the new regulation of CEA, the code of practices are becoming mandatory. I have a slide, I will show it to you later. Let me start the presentation. With respect to the standard, as usual in all my programs which I do, there are 4 standards of IEC, which is the national standard of India at the moment. IEC 62305 are the name. Part 1 talks about the basics analysis and threat. Part 2 talks about risk assessment. So today we will cover up some information, basic information about part 1 and part 2. Plus 62305 part 3 talks about external protection. External protection in the sense protection of buildings and structures. Here the subjects to be considered are air termination, down conductors, earthing, shielding. Also, there are some more subjects such as equipotential bonding, separation distance. All these comes under external lightning protection. Basically, by implementing these protective measures, we are protecting the structure from physical damages and injuries to human beings by touch and step voltage. Then we go to the 62305 part 4. Anyhow, we are not covering part 4 today. It is talking about internal protection, means protecting the electrical and electronic equipment inside the building. Here the subjects to be considered are equipotentialization, SPDs, bonding, shielding, and cable routing. So today our subject is mainly focused on 62305 part 1, 2, and 3, especially onto the subject of protecting a building against arcing and spark overs and fire during lightning, and protecting people from touch and step voltages. So here the lightning protection level, anyhow, we will discuss this in detail in later. One moment. I have made some small changes, as I said today, because of my change in the laptop. It's creating some small trouble. Anyhow, let me go through it, then I will come to know. Okay. Type of lightning. First of all, we should understand that the lightnings, there are intra-cloud, inter-cloud, and cloud-to-ground lightning. There are 3 types of lightnings. So basically, out of these 3, when we talk about protection of structures, we have to think of cloud-to-ground lightning. The first 2 means the inter-cloud and intra-cloud create coupling of surges into the power and signal lines. The third creates serious damages such as fire, explosion, and touch and step voltages and failure of electronics. So today's our discussion is mostly on cloud-to-ground lightning. Also, we should also keep in mind that the 95% of lightning strikes between cloud to ground are negative strikes. Less than 5% is positive strike. I have put here 1/200 microsecond, and for the positive strike 10/350 microseconds. We have to once when we talk about lightning protection, we always talk about 10/350 microseconds. 10 by, and the engineers always say 10/350. It's very heavy. It's very strong. The energy is very strong. It can create a lot of problems, and a normal system may not work in 10/350. And all these explanations may be given. But we also should think that the negative strike, the wave shape is 1/200 microsecond. The 10/350 and 1/200 microsecond will be explained later. But just for your information, 95% of lightning strikes are negative strike, and about 5% are positive. In negative strike, the current 1/200 microsecond means the rate of change of current is very high. means sparkovers or flashovers and couplings will be very high, whereas in the 10 by 350 microseconds, the energy is going to create problem. These are very well explained in the 62305 part 1. Now, cloud to ground lightning consists of two parameters or two types, let me say. First one is the impulse current and the next one is long duration current. Impulse current means a current flow for a short duration of few microseconds, for example. So it goes from zero to peak and then reduces to back to zero in a very short time. Long duration means the current will be smaller, but it flows for a longer duration. The current parameters, the lightning current parameters and IEC 62305 are based on the results of SIGRI data. The SIGRI, the Council of Large Electrical Transmission Companies, they publish the data, and basically the data in 62305 are from SIGRI data. Examples of lightning flashes to a complex electrical system. Here, a complex electrical system, in the sense, just to give an example, what kind of lightnings can create harm to a building. There are several reasons. First one is, example, the lightning strike on an extra high voltage transmission line. Second one is lightning strike on the transmission line. Third is lightning strike on the low voltage transmission line very closer to the building. Fourth one is direct lightning strike on the building. Then you can see some of the examples here. All these are going to create trouble in the electrical installation. But today's topic, as I said, is mostly focused towards the building, that means the structure. So some of the examples. Also the lightning strike which is on the closer to the building or closer to a line also creates trouble. These very well are included in the standard. Now, with respect to problems to human being, one is step voltage. Once when the lightning current flows through the soil, voltage gradient is created, and a person who is standing across this gradient, through the legs, the current may flow. As a result, he may get injured. This is applicable for living beings. So all living beings, the step voltage is going to be a trouble. Similarly, touch voltage, if somebody touches a metallic part which is energized due to a lightning, and if the person is standing on the ground and touching some energized parts, of course, the touch voltage will flow through the body and people can get hurt. So touch and step voltage are the main reason for accidents of human being. However, in our last webinar, we discussed these issues. That means protecting people outside structures are discussed very well. So today we are not going to explain these subjects. Today's our subject is mainly for the protection of building. A typical lightning strike consists of a main discharge, means there is a discharge, the initial discharge or the main discharge where a majority of the energy is discharged. Then after some time, there can be, a time difference, time between discharges, and after some time, there can be a subsequent discharge. A subsequent discharge means sometime one subsequent discharge or sometime several subsequent discharges up to a maximum of 30. And there are chances where sometimes there is no subsequent discharge as well. Now, this is the real lightning impulse or real lightning pulse. It consists of main discharge and probably several or one subsequent discharge. Now, when we design lightning protection system, the most important subject is the protecting building or protecting metallic parts or protecting the building from flashovers, heating and arcing and fire. Here, the main discharge is the most important, which contains majority of the energy. So the components which is used in the lightning protection system, such as the air termination, the conductors used, the earth electrodes or the earth termination system, joints, clips, clamps, all those components ideally should be able to withstand the main discharge because majority of the energy is flowing during the main discharge. For this purpose, the IEC had proposed the wave shape for positive lightning strike, which is simulated in a laboratory in the form of a 10 by 350 microseconds impulse. So sometime people ask 10 by 350, is it a lightning always looks like 10 by 350? No. The laboratory simulated equivalent energy wave shape is 10 by 350 because in order to make a protection, you need to have standardized the components, standardized the wave shape, standardized the test methods are required. So to standardize the energy content, 10 by 350 is accepted in IEC as the standard energy wave shape of a positive lightning strike. Similarly, for a negative lightning strike, it is 1/200 microsecond. So now the problem here, one of the issue which we always try to consider is, let us say, for example, the primary discharge in case of a class 1 or lightning protection level 1 strike is 200 kiloampere. We say 200 kiloampere 10 by 350 microseconds means the current goes from 0 to peak. Here the current is 0, then suddenly there is a current flow and it goes to the peak in 10 microseconds. So the average rate of change of current is about 20 kiloampere per microsecond. This is one case. If we look at the subsequent discharge, here the subsequent discharge, the recommended wave shape is the maximum current is about 50 kiloampere and the rate of change of current, it reaches peak in 0.25 microsecond. In the sense, the rate of change of current in this particular case, subsequent strike is about 200 kiloampere per microsecond. So in one case, 20 kiloampere per microsecond, the initial impulse, and in case of a subsequent discharge, the rate of change of current may be 200 kiloampere per microsecond. Now, this 200 kiloampere per microsecond probably can create a different kind of issues. These 20 kiloampere per microsecond, of course, these values are very high. I have considered the maximum values just to inform you that it is not only the current, the steepness of the current is also a subject which need to be discussed or which need to be considered when you design a lightning protection system. So, lightning is not a DC current flow. Lightning, sometime we can even say that it's a high frequency current. That is not the right way of calling, but still people call it as a high frequency phenomena. And some standards even say that lightning frequency is typically 25 kilohertz. Now, once when this current flows through a conductor, I'm just showing a wire, let's say 16 square millimeters of copper wire, or let's say 25 square millimeter wire, copper wire, 1 meter. So 1 meter wire will have approximately 1 microhenry impedance. Once when the current 20 kiloampere per microsecond flows through this 1 meter wire, what happens is, between this length, 1 meter length, there is a huge potential drop or huge potential difference is created. If the current is, let us say, 200 kiloampere 10 by 350, then the potential difference between 1 meter wire length is about 20 kV. And if it is a subsequent negative discharge, then the potential difference created is about 100 kV. In case of a subsequent impulse, the potential difference in 1 meter wire is about 200 kV. So this is just to explain you that if the length of the wire is more and more, the potential difference created in the wire is more. So an enemy to lightning protection is more wire length. This is why we say whatever the connection or down conductors which you are making in lightning protection system, it has to be as short as possible. If you make a long wire, then you are in trouble because the potential drop in the wire will be extremely high. Wire or conductor will be extremely high, which will actually destroy the installation. So basically, transient current flowing through conductors create high potential difference, resulting in flashover to other metallic installations. Example, down conductor to steel in RCC and PEB, metal facade, metal doors, power lines. So before the current starts flowing through the conductor, the down conductor, it actually flashes over to all the nearby metallic installations. And if you really wanted to separate this particular the conductor, if you wanted to keep it away, then we have to calculate, and sometimes we have to keep it far away from other metallic parts of the building, which is practically very difficult. So just the simple conclusion is length is an enemy, or wire length is an enemy to lightning protection. More length means more problem. Less length means your lightning protection is going to be more efficient. The length means the length of the conductor where the lightning current is going to flow. So this is one of the parameter. In the sense, once when you design lightning protection system, you should avoid unnecessary routing of conductor. If you can take the conductor through a straight route, you should take it straight as much as possible and avoid bending and routing through different parts of the building. Similarly, the current flow, once when the current flows, so the lightning current flows through the conductor, let's say, for example, one conductor, it creates a high electromagnetic effect. This current flow through the conductor creates a very big electromagnetic effect. Imagine the complete current is flowing through one conductor. Means you will have EMI effect, electromagnetic effect, at probably sometime several tens of meters. Now, if you have two down conductors, the current is divided into two. The effect of electromagnetic effect of the current flow is reduced to half, for example. If you have multiple down conductors, let's say 10 down conductors, then the effect is reduced probably 10 times. And if the number of down conductors are, let's say, 100, so the effective effect is much, much lower. So the second subject of lightning protection, while designing lightning protection, you should always consider that there shall be multiple down conductors. More number of down conductors is best for the building. The standard recommends some minimum number of down conductors, but if you can make even more than that, the effect, the electromagnetic effect will be less. Electromagnetic effect is going to hurt your electronics, electrical and electronic installations. So one is more length is a problem. Number two, less down conductors is a problem. Number three, if you have a bend, if you make a bend in any of the conductor, say for example, down conductor, what happens is the opposing magnetic field on a bend will destroy the conductor. So bends must be avoided. If you make a bend, if you have no other choice, and if you wanted to make a bend, then there are some minimum bending radius. We have to calculate those and we have to consider those very well. If we make a 90-degree bend, even if the bend is made above a brickwork or a concrete work, the forces which is going to be created in this area will be enormous, so that it can disturb or destroy the entire concrete as well. So this has to be taken care very well. Bend is an enemy to lightning protection. So the recommendation is to have the conductors as straight as possible. Then the last one is a loose contact. Loose contact will create a big problem. It is not like in a 50 hertz AC, the loose contact is creating heat. It is not like that in lightning, because lightning has got a parameter which is called as specific energy. Specific energy scientifically is connected to the resistance of this particular joint 1 ohm, joint resistance of 1 ohm produces an equivalent heat of about 6.3 megajoules during a lightning current of 200 kiloampere flows through it. So the amount of heat which will be produced in the joint will be enormous. So what we should do is the joints shall be made in such a way that the resistance of the joints are negligible. What you should do is you should use either exothermic welding, or you should use components which are tested for withstanding lightning current. So lightning current tested components shall be used in all joints. So basically, length is an enemy. So always try to use the shortest length of a conductor. Large number of down conductors are required. It also means less down conductor means you will have more problem. The third one is bend. Avoid bends, make it as straight as possible, and avoid loose contacts. Make all the joints with the tested components. So these 4 are some tips which I can give while designing lightning protection. Of course, in Cape, all of you know that I have my company is Cape Electric. So in Cape, we have a design team. One moment, please. So we have a design team in Cape, and we have about, I think, 15 or 16 people in our design team. So we used to do lightning protection design. So once when we get the drawing from the client, we ask a lot of questions to the client, because in order to ensure that the design is made in a good way. But most of the time, the clients say, why you are asking so many questions? Your competitor or the other company, I gave the drawing at 10 o'clock and they finished the design at 11 o'clock and gave it back to me. And your company is taking 3 days or 5 days to make a design. You are lazy. You are very slow. These comments we used to get. But please note that designing lightning protection is not a simple job. We have to really understand in deep, and then only we can do it. Our engineers are designed to do a proper designing. That is the reason they ask questions to the customer or to the designer, and try to make a good design. So it may take sometime 2-3 days or even more. So I just try to explain the system with a simple explanation. Not for an engineer. This explanation may not be fit for an engineer, but this explanation will be, sometimes it works for a non-engineer as well as people, those who have little knowledge on electrical engineering. So I try to compare. Of course, this was made by Professor Chandima Gomes a few years back. I think 15 years back, he was explaining in this way and everybody understood. Then I also started explaining in the same way. Let me try to do it again. So imagine you have a glass pipe and you have a sponge, and you have one bucket or one mug of water. You pour the water slowly into the glass pipe. So you know what is going to happen. So some of the water goes to the sponge absorbs the water, and the rest will be inside the glass pipe, and after some time the whole water goes to sponge. So it takes some time, probably 10 seconds or 20 seconds for the water to go to the sponge fully. On the same time, the same sponge and the pipe, if you try to pour the water quickly, very fast, then what happens is the pipe will be overflowing. Before the water reaches the bottom, the whole thing overflows, and only a little amount of water goes to the sponge. Most of the water overflows. This is what happens. This is, practically what happens in case of a DC or a 50 hertz current flow. The system which is going to happen is on the left side. The current is slower. In case of a transient or a lightning, the current flow is very quick, very fast. The system is not just like what we think. So in case of a DC or a AC 50 hertz current, probably one conductor is enough to carry a current, whereas in case of lightning current, you are not. This system, the same idea will not work, because here, in case you can see the limited potential rise, and in case of the second case, where the current flow, where the water is poured very quickly, or imagine it's a transient current flow, unlimited potentials are created. So I also try to explain it in another way. Earlier, we were doing some classes for some school children. So where these figures were used, I will try to explain again. Not, I'm sure all our participants are engineers, but still, just to understand the system. Now you see, you have a pipe which can withstand, let's say, a plastic pipe, which can withstand 1 bar pressure, and its bottom is sealed. And you try to pour water with 10 bar pressure. And you know what happens? Once when you pour the water, at the top itself, it explodes. In the second case, the same pipe, you see that, you imagine there is a small hole in the pipe, but the pipe can withstand only 1 bar pressure, and you are putting water with 10 bar pressure. Of course, little bit water goes inside, but then immediately the pipe explodes. Third case, the pipe is completely open. You have a open pipe, but the pipe can withstand only 1 bar pressure, and you are pouring 10 bar water. Of course, the pipe is going to explode. So these 3 pictures can be explained in such a way that the first one on the left side is like one down conductor used, and the down conductor is not terminated to the earth electrode. Lot of buildings in India, you can find out the one single rod lightning protection, and most of the time the down conductor is disconnected at somewhere. As a result, this is what is going to happen. At the top itself, at the air termination itself, the lightning current is going to flash over. It is going to destroy the whole installation. Similarly, the next one, imagine the single down conductor is connected to earth electrode, but very inefficient connection. In that particular case, there will be flashover somewhere again. And the third one, there is a single electrode. Most often the ESC devices which you are seeing in the country having one air termination, one down conductor, and one earth electrode. Once when the current flows, this is what is going to happen. The whole installation will be destroyed. There will be flashover. The solution with respect to lightning protection. Then what is the solution? The solution is something like this. It is like you have a larger, like a water tank at the top, or interconnected pipes, and all these gray color are, imagine these are the pipes. Now, if you put a high pressure water, let us say each of the pipe can withstand good water, but you see how the water which we are going to pour is limited. It's only 1 bucket of water, not so much water. So in this particular case, a bucket of water will be flowing through all the pipes, and the amount of the chance of damage is very less. So this can be explained as what we are supposed to do to system. As I said, the place of the school children's, this is not for engineers, but still sometime the questions at the top, you have an air termination mesh plus naturally available steel installation in the roof. So we make a very good equipotential bonding at the top with a lot of metal interconnections. Then there are several down conductors, and there is a very good earth termination system. Basically, this is achieved by interconnecting different metals. So basically, this is the system which is followed globally as mandatory for the last several years. And this concept means a large air termination system consisting of rods, horizontal conductors as a mesh, everything interconnected. Then there are several down conductors, and finally a large earth termination system, either as a ring conductor or as a foundation earth electrode. This is what is explained as lightning protection system in National Building Code as well as IEC 62305. But please excuse me, I explained it as an example. Now, air termination. The first job of lightning protection is to design the air termination system. You can see here lightning protection class 1, 2, 3, 4. Air termination is the system or the method or the interconnected metallic arrangement which we are making at the top of the building in order to avoid a direct lightning strike into the building. The first method is in case of a flat roof building, you can make a mesh. Example, the size of the mesh is provided in the standard. You can also go for a vertical rod, which offers certain angle of protection, not like 200 meters or 100 meters. Each of the rod offers certain angle of protection, and you can also use the rolling sphere method. Once when we talk about rolling sphere method, people always ask, what is the basis of the radius 20 meter, 30 meter, 45 and 60? So what is explained in the standard is R equals 10 into I to the power 0.65. This is the rolling sphere calculation included in the standard. And this I depends upon the charge in the cloud. And this I is related to a parameter which is called as you can see here, the lightning conductor, the lightning downward leader comes. Then there is an upward streamer or the answering leader from each of the grounded object, such as the tree, also such as this particular transmission line. Now, the lightning strike get connected to the transmission line, and the final jump is called as the striking distance. The rolling sphere or electrogeometric modeling is made based on the assumptions or based on the calculations of the striking distance. Striking distance is calculated based on the charge or the expected lightning current. Let's say, for example, 200 kiloampere. So if we apply that particular the formula, then you get the value. So based on the striking distance, the rolling sphere radius is calculated. Now, positive strike, just as an example, because people always think that lightning current comes from the cloud and it goes to ground. Actually, it is not like that always. Positive strike, for example, the current flow will be from the cloud to the ground, also from the place where the lightning has struck to all the metallic installations connected to that particular structure. So the direction is just shown just for an example. Similarly, in case of a negative lightning strike, the current flow will be opposite. Sometimes people try to explain that you need one SPD for one direction and another SPD for another direction. These are actually wrong. The devices and the components which is used in lightning protection, they are capable of handling both the current flow of both the directions. So positive is in one direction, negative lightning current flow is in another direction. Similarly, if you look at a building, you see here there is a lightning strike. The current flows to the ground, and to the connected services, the current flows outwards from the building to the nearby buildings. So in case of negative, it is the opposite. So positive and negative strike, you must be careful. The current flow is opposite. Lightning in to a nearby object. Just to explain you, there is a building and now a low voltage line is connected. Generally, this is typically applicable for low voltage consumer premise houses. Let's say there is a tree and the lightning has struck the tree. Generally, what we read in newspaper is, or what we find there is as a result of this lightning strike is the electrical and electronic in the house has burned, the incoming meter board burned, then the DBs, switches, inverter and TVs failed, and to the neighbor's house also some items, some of the electrical or electronic appliances failed. This is what generally happens. So this phenomenon is once when the current flows through this particular tree, there are 2-3 chances. One of the chances from the tree to the metallic installation, there can be a side flash. If there is no side flash, the current flows through the ground, and here at the ground, a high potential is created. So the potential rise at the ground will be extremely high with respect to a faraway place. So low voltage is to the faraway place. If we look at the connected service, that means the 230, 400 volt line, the line is connected to earth, which is nothing but the neutral earthing of the transformer, which is far away from the building. Imagine it's 200 meters away from the building. So for this particular power line, the building and the nearby area is at a high potential, and the line, which is 200 meters away, you have a totally different potential. So what happens is, the potentials are extremely high. As a result, it breaks the insulation of your electrical installation. The electrical installation's insulation is broken by the way of arcing or spark over, or some of the electrical items got burned, basically arcing or spark over. Then the current will flow back to the source, or sorry, it flows back through these connected services. A partial current also goes to the neighbor's premise. That means all the connected line, wherever these lines are connected, will experience a partial lightning current. So basically, this is what happens. The house near to the tree will have major failure, and all the connected equipment, all the connected neighbors' houses also will have failures. You can find such examples, or you can find out these very well. Now, once when we talk about lightning, the impulse current wave shape, very important. We always say 10 by 350 microseconds, and people always have doubt. What exactly is this 10 by 350 microseconds? 10 by 350 is explained in this fashion. It is the energy equivalent of a positive lightning strike. Means the lightning current, see here is the current flow. It goes to the peak and it is reducing. This is the impulse current. The current goes from 0 to peak. T1 is 10 microseconds, and T2, that means from the starting up to the half of the current reduction, it is T2. Sorry. So the T2 is 350 microseconds. You can find out from this wave shape the explanation of 10 by 350. Current goes from 0 to peak in 10 microseconds. Then it comes to half value in 350 microseconds. This is the simple way of explanation. But now sometimes people try to explain it is not exactly 0 to 100 percentage. It is in this way, that way. Actually, it's not important. We have to find out analysis of 10 by 350 is not going to help anyway. So I is the O1 is the virtual origin. You can see here, this is the virtual origin. I is the peak current. So here is the peak current. T1 is the front time. T2 is the half time to half value. So typically, definition of impulse current parameter, typically T2 is less than 2 millisecond. So, but for the purpose of standardization, 10 by 350 is taken into consideration. Similarly, the long stroke, you can find the picture in IEC 62305 part 1. Long stroke is a current flow or a cloud to ground current flow, which is having a lesser current in comparison to an impulse, but the duration is long. So long duration, and it consists of charge. Basically, the charge is going to heat up, or charge has got certain effect. Actually, these, the positive or the negative and the long duration strokes are analyzed very well in the standard, and the effects are also included in the standard for the designer to design an appropriate lightning protection system. For example, here, possible components of downward lightning strike. For example, it can be only one positive or negative strike. It can be one positive or negative. You can see one impulse and a long duration stroke, multiple short duration strokes. Then the current is always negative. It is not positive. multiple, there is one initial strike and multiple strikes, long and short duration, then the strike is always positive. And these kind of typical in flat territory and lower structures means the height of the building is lesser, and in flat territory, these are the chances of strike, and you can find it out in 62305 part 1. Similarly, the shapes are analyzed in a different way for higher structure, exposed or high structures. So these are the different wave shapes, positive or negative strike. You can see here there is one impulse, then there is a long stroke and a short stroke. You see, basically, this is just for the designer to understand the application, and if necessary, he can take extra measures. For example, each of these stroke, for example, here I am moving long stroke. Long stroke is going to create a typical kind of failure. If the designer is aware that your building is a high-rise building or exposed building in a hill, for example, then he can put some extra measures in the, for example, air termination or down conductor. As a result, such a possibility can be reduced. So these basically it's a high-tech knowledge, but basically the designers are supposed to have some idea about it. As a result, the design can be made more perfect. The 62305 part 1 also gives you this kind of a table. I put the picture in a table. For example, type 1 impulse. If the lightning strike is only one impulse, it can be either positive or negative polarity, and it is possible in flat territory and to low structures. Whereas in case of exposed and tall structures, these are the possibilities. Now let me skip it, as I have already shown it in the picture. Values of probability as a function of lightning current. So here, please note that 100% protection probably is very difficult, because we really don't know what kind of lightning is going to hit. So the standard considers up to 200 kiloampere lightning strike. Let's say, for example, from 3 kiloampere up to 200 kiloampere is what is considered in level 1 protection. It also means that the lightning is not limited to 200 kiloampere. There is a chance of 0.005% probability for a lightning strike of 300 kiloampere, 0.002% for up to 400 kiloampere, and 0.001% for a lightning strike of 600 kiloampere as well. All these exist. There were some claims in some of the meetings where people claim that Orissa recorded 400 kiloampere lightning strike, whereas IEC is considering only 200 kiloampere. Those are wrong. The standard considers only up to 200 kiloampere. So if a customer wanted to have a higher current withstanding capacity, he can design. The tips are given in the standard. But as standard, level 1 protection consider up to 200 kiloampere. If you wanted to have a higher degree of protection, you have to have extra measures. So now the current consists of, the impulse consists of a peak current in amperes, kiloamperes. There is a charge, specific energy, and rate of change of current. For the purpose of making an engineering design, the effect of lightning need to be analyzed, and to get the effect of lightning, these are the parameters which is analyzed and concluded in the standard. In the sense, lightning current consists of a current flow, a charge, a specific energy, and a rate of change of current. When we design lightning protection system, actually these are very important. For example, the mechanical effect of lightning are related to the peak value of the current and to specific energy. Mechanical effect means, example, bending or some of the down conductor is pulled out of the wall. It is due to peak current. That means the current and the specific energy. So methods to handle the current and specific energy is also explained in the standard. And now the effect, for example, the mechanical effect of lightning are related to the peak value of the current and to the specific energy. The thermal effect are related to the specific energy when resistive coupling is involved and to the charge when arcs develop to the installation. For example, the thermal effect are related to specific energy where resistive coupling is involved. This is what I told. In case of a loose contact, the amount of heat produced, there is a resistive connection. The connection is having certain resistance. The amount of heat produced depends upon the specific energy of that particular lightning strike. So resistive coupling is related to specific energy. Over voltages and dangerous sparkings are related to the di by dt, means the rate of change of current. Over voltages and dangerous sparking caused by inductive coupling are related to the average steepness of the lightning current. Each of the single parameters, the current, the charge, the specific energy, and di by dt, tend to dominate each failure mechanism. Please note that these are just copied from the IEC 62305 part 1. You can find this information in the standard. It is not, the information is not I am making, it's from the standard. So why I explain in detail is, if you wanted to make a perfect lightning protection system, you should understand the effect, you should understand the contents of the lightning, you should understand what kind of area we are talking, what kind of building we are talking, what kind of currents are expected in that area, and then we have to make a proper design. This is what I told in the initial time. The engineers in Cape sometimes may take 2, 3, 4, 5 days to make a design, because we are trying to analyze as much possible and trying to make a very good design. So I'm so sorry to customers, those who are asking, saying that I want a lightning protection design in 1 day. Most probably it is very difficult. Now, this particular table you can find in the standard. It consists of, this is actually analyzing different contents of each of the lightning strike. For example, first positive impulse, first negative impulse, subsequent impulse, long stroke, and flash. These are the contents of different kind of lightning. Probably there is a first lightning positive impulse or first negative impulse. There can be a subsequent impulse. There can be a long stroke and there can be a flash. Now, lightning protection is divided into 4 levels: LPL1, LPL2, 3, and 4. LPL1 talks about first positive stroke 200 kiloampere, for example. LPL2 considers 150 kiloampere. LPL3 considers 100 kiloampere. So the peak current is specified here. The impulse charge and specific energy. In case of level 1 protection, 200 kiloampere is the current. The specific energy to be considered is 10 megajoules per ohm, means approximately the heat produced in 1 ohm resistance. Once when that particular current flows, or once when a current of 200 kiloampere 10 by 350 flows through 1 ohm resistance, the approximate energy or the heat produced is about 10 megajoules. That is what it is. Now, the charge, for example, is about 100 coulombs. The di by dt, average steepness. But please note one point. The first stroke has got 200 kiloampere strike. The current flow, the current is 200 kiloampere. The first negative is having 100 kiloampere. The subsequent impulse is having 50 kiloampere. Whereas long stroke and flash, we are not talking about a current. The impulse charge and specific energy, these are actually not applicable for the negative strike and subsequent impulse, long stroke, flash. These two parameters, the impulse charge and specific energy, is applicable only to a positive impulse. That means if the failures are due to thermal and mechanical and thermal, then most probably the lightning is a positive lightning strike. We can actually analyze while doing the analysis of a failure or while designing the protection mechanism. These values are helpful for the designer to understand and make some additional measures if necessary. Normal buildings, probably it's not required, but for special buildings, you can go for such deep designs. So the impulse charge and specific energy is applicable for first positive strike, which is exactly not applicable for the first negative stroke. That means now you have to also correlate this with the 95% or more than 95% of lightning strike is negative and about 5% is positive. So the average steepness in case of first positive stroke is 20 kiloampere per microsecond, and in case of negative strike, you see this 100 kiloampere per microsecond or 100K, and in case of subsequent 200K. Now, the average steepness is going to create surges and flashover. Surges and flashover in the sense this is going to create a big potential difference, and it can flash over to all the nearby metallic objects, and it can also create surges, transient over voltages due to different coupling mechanisms. So we have to be very careful. Average steepness, as I told, it is directly related to the length of the conductor. Specific energy is related to the resistance of the conductor. So each of these parameters can be connected to some parts of lightning protection system. For example, peak current, it can be related to the size of the conductor. So all these matters once when we design a lightning protection system for a critical installation, not for a normal building. So please note that average steepness is applicable in case of positive 20 kiloampere per microsecond. Negative stroke, first negative is 100 kiloampere, means the surges and flashover in a negative stroke will be more severe than a positive strike. The surges and flashover during a subsequent impulse will be much more severe than a positive strike. So these values you can find from the IEC 62305 standard. But to understand and implement it, it is an engineer's job. Then we go to, so these are the contents up to until now, these are the contents of the part 1 of IEC 62305. Then we go to part 2, which is nothing but the risk assessment. So in order to design lightning protection system of a building, finally, the purpose of lightning protection is to protect your building. That means if the building is not protected, you are going to have some economical loss. So we have to evaluate, we have to find out whether the what kind of economical losses are expected in a building, and with how much minimum cost you can avoid the economical loss, what kind of minimum expenses you can make to avoid the failure or to avoid the economical loss. So for this purpose, risk assessment is made. Here at one side, the risk involved and the cost of failure is calculated. For example, the location of the building, the whether it is in a hilly area, the number of thunderstorm days, then is it near to a high-rise building? Is it near to a tree? Is it near to a transmission tower? All these things are considered. The size of the building is considered. The type of services are considered. The number of people are considered, and criticality in case of failure. All these are considered, and the risk involved in a typical building is calculated. Also, the cost of failure is calculated in a scientific way in IEC 62305 part 2. So by making this particular calculation, on the other side, you have the minimum required protection. So you can go for a lightning protection system at the minimum cost without tolerating the tolerable limit. The tolerable limit is for human safety 10 to the power of -5, means out of 1 lakh lightning strikes, 1 can harm a person. Electronics 10 to the power of -3 means out of 1000 lightning strikes, 1 of the lightning strike can create a failure. People also try to analyze how this is possible. Imagine you are in a city, or you are considering 100 square kilometers. 100 square kilometers. The lightning flash density is 4 per year per square kilometer. So 100 square kilometer, 4 into 100 is approximately 400 lightning strikes. So 1 year in 100 square kilometer, you expect 400 lightning strikes. So here 10 to the power of -3 means each year 400. So out of 2.5 years, you can expect 1 electronic failure. In this entire area, electronics failure during lightning or due to lightning must be limited to 1 failure per year in a place where the lightning flash density is 4 per square kilometer per year, and we are considering 100 square kilometers of area. This is how it is. So the tolerable limits are given in the standard. Now the risk assessment is made in order to find out the minimum expenses with which a reliable lightning protection can be made. The considerations are, for example, there are 4 types of lightnings which is going to create failure in a building. S1, S2, S3, S4. Flashes to the structure, flashes near the structure, flash to the service, and flash near a service. These are the 4 causes of lightning which can create a damage, and the damage can create a loss. So basically, each of these source, let's say for example, source S1 means a direct lightning strike into a building, directly on the building. It can create injury to living being, physical damage, and failure of equipment. So the damages, there are 3 types of damages a direct lightning strike onto a building is going to create. This is D1, D2, D3, injury to living being, physical damage, and failure of electronics. Now D1, injury to living being. How this is, what kind of loss we are going to have? First one, loss of life and loss of economics. So in case of D2, physical damage, loss of life, loss of service, loss of cultural heritage, and loss of economic. Basically, the losses are classified into 4 types: loss of life, loss of service, loss of cultural heritage, and loss of economics. Out of this, loss of cultural heritage is a very important subject which we generally neglect. In a normal building, you don't need to consider about the loss of cultural heritage, whereas in a very critical, in a culturally or in heritage buildings such as temples, forts, and all, we have to be very careful while designing lightning protection system. Similarly, failure of electronics, the damage number 3 is going to create loss of life. For example, in a hospital, an equipment failure may be harmful to a person. That is what it is mentioned here. Then loss of service means an electronics failure may be destroying a service to a building. For example, the telecommunication room or public telecommunication line has got broken, or it has burned, failed. As a result, the service is lost. So there is no, for example, the telecom tower has got a lightning strike and the signal is lost. That is what is told as loss of service. And the 4th one, loss of economics, means direct the amount of loss which we are going to have. Similarly, S2, flash near the structure is not going to create the first 2 damages. The flash near the structure is going to create a failure of equipment directly, and failure of equipment is related to loss of life, loss of service, and loss of economics. S3, for example, a direct lightning strike into the service, onto the connected service, is going to again create all the 3 damages. For example, injury to living being, physical damage, failure of equipment. Sometimes people ask how a strike onto a service or to a flash on the power line, how it is going to injure people. Of course, if somebody is using some electrical appliances, of course the person will have a problem. So he can be injured. So physical damages are also possible, means the lightning strike on the service line, on the 230-volt power line, has destroyed the entire distribution board, for example. Then failure of equipment. So these 3 damages are expected due to the cause S3. And out of these 3 damages, we can have loss of life and loss of economics. D2, again, all the 4 type of losses. Then in case of failure of equipment, all the 3 losses. Similarly, the last one, S4, flashes near the structure or near the service, for example. The flashes near the services can also create a failure of equipment. The damage is failure of equipment, and the losses are the 3: loss of human life, loss of service, and loss of economics. So basically, this is the way the risk assessment is made. The amount, the type of the strike, and the type of damage, and the type of economic loss which is going to happen due to a failure is analyzed scientifically, and the loss of each of these parameters in a typical building is calculated. For example, here this table S1, S2, S3, I'm sure that the subject will be too technical. It will be sometimes very difficult to understand. The purpose of showing this or explaining these slides or explaining the risk assessment is generally we used to get a request from customers to make a risk assessment. Then we have a software and we put the values, maybe 20 questions, and put the values into the software, and the software gives you lightning protection level 1, 2, 3, 4. What I am seeing in the market is the purpose of making risk assessment is to make the minimum expected protection, or the minimum level with which a building can be protected. But most of the time, the arguments are you are giving level 3 protection, but all the other competitors are giving level 1 protection. How come this is? So the answer is, please understand that the risk assessment is to find out what minimum is required. Now again, going back, there are 4 type of sources, 3 type of damages. Each of the damage is related to loss of, for example, L1, loss of human life. S1, S2, S3 is creating each of these particular loss of human life. The loss of public to serve or loss of service, you can see here some are exempted, loss of cultural heritage, some are accepted. So based on this table, each of the loss, the approximate risk is analyzed scientifically. So the risk is analyzed, and finally the result is given in the form of 4 levels of protection: level 1, level 2, level 3, level 4. Finally, for the user, or for the engineer who is making the lightning protection design, he has to find out what level of protection, minimum protection is required for a particular building. For example, level 1 considers current from 200.9 kiloampere to 200 kiloampere. So the probability is 99%. You have seen in the earlier slide. Level 2, 5.4 to 150 kiloampere. Level 3 up to 100 kiloampere. Level 4 up to 100 kiloampere. The idea is, every building you cannot make a level 1 protection. Of course, you can make it, but then it will be very expensive. But spending that much money for a building may not be economical. So in order to find out an economical solution, the levels are provided in the standard. Now, the National Building Code also recommended the levels as per this particular table. For example, computer data center, military application, high-rise hotels, hospitals, nuclear power stations, airports, essential services such as telecom, you go for level 1. Low-rise hospitals, hotels, explosive zones in the industry and chemical sector, fuel retail, outage, gas stations, compressor stations, and similar installation, you go for level 2 protection. Then the buildings such as school, bank, residential building, temples, churches, mosques, you go for level 3 protection. This is the recommendation in National Building Code. So you can also make use of this particular table, and you can go for the recommended levels in the National Building Code. But as I said, if you make the risk assessment by making some small changes in the questions or in the answers, every building we can try to make a level 1 protection. Even a church or a mosque or a residential building, 1-floor residential building, we can make we can get a result of level 1 protection. But the idea is not to find out the maximum protection. It is to find out the minimum protection required for a building. When it comes to lightning protection, always the challenge is this non-standard lightning protection, because the lightning protection is not complete if we don't discuss about the non-standard protection, such as the early streamer emission device, which is called in India as the advanced lightning protection system. So my conclusion is this is a way of fooling people. So the claim is it protects several hundreds of meters, 100 meters or 100 plus meters of radius. It requires a very simple one down conductor, 70 square mm insulated conductor, which is running from top of the building up to the bottom. And then it is connected to one earth electrode. This will protect the electrical installation or the entire building from lightning. So of course, this is a non-standard system. National Building Code recommended not to use this system, and it will not provide any safety. Even the French standard do not explain lightning protection in this fashion. So one down conductor and one earth electrode is a disaster. We call this, the first disaster is the story behind the enhanced protection radius of the ESC device. The second disaster is single down conductor disaster. And most often these devices are installed in multi-storied buildings and the down conductors are routed through electrical shaft. So I had a lot of discussion in last 15 years with builders. Once when I tell that don't use this particular device, then they say, no, the X company from France or the Y company from Australia, they are very reputed worldwide. So they provide one rod protecting me and all my neighbors, and the down conductor can be routed through the shaft, electrical shaft. So please, for such arguments, please download the French code NFC 17102 from the Google. You can download it free of cost, the English version, and you please go through it. This single down conductor, single earth electrode is actually, these companies are, sorry to use the word, they are actually cheating the customers. Now, coming back to the regulation, for your information, the Central Electricity Authority published the regulations 2023 on 8th of June. And here in the regulation, earlier regulation, the old regulation, chapter 3 contains the code of practices may be followed. It was only a recommendation, but in the new regulation, save otherwise provided in these regulations, the relevant standard, including National Electrical Code and National Building Code, shall be followed to carry out the purpose of these regulations. This means, in order to comply to the national safety regulations made by the Central Electricity Authority, the recommendations of National Electrical Code and National Building Code shall be followed. Means National Building Code and National Electrical Code has become a mandatory requirement. May be followed is changed to shall be followed. You can Google the meanings of may and shall in a standard or in a rule regulation. Shall is a mandatory requirement. So similarly, in the same regulation, CA regulation 2023, regulation number 38, sub-regulation number 3, and sub-regulation 6, you can see lightning protection building shall be as per the relevant standard. The relevant standard, if you look at the definition, it is the Indian standard, means the National Building Code, National Electrical Code, IEC 62305, and so on. So now all these standards do not recommend non-standard lightning protection system. Now, please note that there is a claim in the market. People claim that there is a high court case and the high court ruled against National Building Code and all these nonsense. Now the regulation has written very clearly to follow National Building Code. Now it has become a legal requirement for every building to follow lightning protection system as per IEC 62305 and National Building Code. That means the non-standard early streamer emission. For example, here what is written in the NBC, all type of air termination system shall be positioned in accordance with the clause 11.5.2. The individual air termination rods should be connected together at roof level to ensure current division. Radioactive air terminals shall not be allowed. Any other kind of air terminals like dissipation system, ESC air terminal, CSC air terminal shall not be acceptable. So the last sentence, the last line, any other kind of air terminal like dissipation system, ESC system, and CSC, ESC, all these are shall not be used. It means the National Building Code very clearly has written the NBC is not considering these non-standard items in lightning protection design. So if you use ESC systems in building, in solar PV, or in industry, please note that now it is illegal. Not only now, earlier also it was illegal, but there was some confusions. But now anyway, it's very clear that it's illegal. Now, the values, let me skip it. I will try to conclude the presentation a little bit quickly. As I explained earlier, the lightning protection system consists of an air termination system. Air termination system can be made as a horizontal grid, like on the left side where I am moving the cursor. The size of the grid depends on the lightning protection level 1, 2, 3, 4, level 1, 5 by 5, level 4, 20 by 20. Similarly, protection angle is with respect to height, and the LPL 1, 2, 3, 4, the heights are given. There is a a picture in the standard, you can refer the picture and you can find out the angle of protection and put a rod and calculate the angle of protection. And similarly, the rolling sphere method, as I said, the rolling sphere radius is based on the striking distance, which is connected to the expected current, and the formula is also given in the standard. So rolling sphere method is a technique which is used to find out the probable place of a direct lightning strike. Rolling sphere do not protect your building directly. It's only a technique to find out the probable place of lightning strike. And in those places, you can use either a mesh or a rod to protect your building. So basically, flat roof building, you have the mesh, the size of the mesh is given. Also, an angled roof, you can use the same technique, the mesh is given. This building, for example, this is the Tiananmen Square. I don't know the name of the building. This is the building in China, the heritage building in China. You can find out the way they have made lightning protection in this particular building. The conductor which you are seeing on the top, actually, if you look at the building, you will not see the lightning protection system. So the LPS is made in such a way that it is made so beautifully that the aesthetic view is not at all destroyed, which is a major subject in India. Architects always say that I don't want to put a lightning protection system in my building because it spoils the view of the building. Please note that lightning protection can be made without spoiling the external outlook of your building. So this is an example. So some of the pictures of this particular Tiananmen Square building, the heritage building in China. Unfortunately, we can't find this kind of an installation in India. That's why I referred the Chinese installation. The protection angle, this table you can find from the standard, and you make the approximate angle as protected. For example, here in this case, the protection angle you know very well, depending upon the height. A building with a rod at the corner of the building, you will have two heights, one at the outside, one towards outside, one towards inside. Both have different angles. So when you make the protection angle, what we need to consider is the protection angle is considering a 2D building, but actually our building is 3-dimensional. So if we don't take care of the corners and edges, lightning will always try to go to the corners and edges of an object. So the most important is to protect the corners and edges of a building. Now, let me explain a little bit more about the rolling sphere method. There are 4 diameters or 4 radius explained in the standard, level 1, 2, 3, 4. So basically, this electrogeometric sphere is used to find out the probable place of positioning of a rod, for example. So in this particular case, positioning simple rods at 4 corners or 4 points of the building is protecting the building from a direct lightning strike. Of course, all the 4 vertical rods must be interconnected, and there shall be multiple down conductors. So here, all the area which is shown in red color are the place where a direct lightning is going to strike, and those areas we are supposed to have either a mesh or a rod. So in a typical building, lightning protection will looks like this. You see a typical building with the solar rooftop installation. There are some rods in order to protect the solar rooftop. Then there is a mesh which is interconnecting the entire building, which is running through the corners and edges of the building. And then there are down conductors, and finally the down conductors are connected to ring earthing, an earth termination system, which is like a ring. The 2 techniques which can be applied here is the protection angle as well as the rolling sphere. Both can be applied and ensured that the lightning is not striking either the building or the rooftop appliances. One subject which we always wanted to consider is the separation distance. Anyway, we will not discuss it today. We will discuss separation distance in a different webinar. Buildings with metal roof. The metal roof can be used as air termination system provided it is meeting the requirements of the minimum thickness, for example, which is mentioned in the standard. If the thickness is, you see two conditions are given here, thickness A, thickness B. Thickness A is to prevent puncture. Thickness B is only for metal sheet if it is not important to prevent puncture, hotspot or ignition problem. Let's say, for example, the typically used in India is the galvalume sheet, galvanized sheet. For example, this sheet normally 0.4 mm or 47 mm is the one which is used in India. So practically in case of lightning strike on that particular sheet, there can be a puncture. If you can manage your building with the puncture, then you don't need any air termination system. But if you cannot, say for example, you have an industry or you have a explosive area or you have a critical installation and you cannot afford to have a puncture, in that case you need to have an additional air termination system connected to the metal roof of the building. So some of the accessories which is used, for example, in industrial building, what we do is there is a mesh and the mesh is directly connected to the roof sheet. But sometimes often people, the engineers, electrical engineers have some kind of apprehension. They say you don't use any metallic conductor, you use an insulated conductor. But sometimes we are forced to use insulated conductor because people think that lightning current will flow over the through the air termination and down conductor. It is actually not correct. So you need to have metallic conductors directly mounted to the sheet. High-rise buildings need number one, separation, and number two, a mesh at the top 20% of the building in order to avoid side flashes. We will discuss this probably in the next webinars. Similarly, a typical building need multiple down conductors. The maximum distance between down conductors are specified in the standard. You see, this is a building and you have so many down conductors in the building, and down conductors has to be all around the building. It is not like all the down conductors you route through one place. No, it has to be throughout the building. It has to be outside the building. It has to be straight without bends if possible, and not through shaft, especially electrical shaft. So similarly, now let me skip this. The separation distance, we will go through it later. Let me go to the last part, the earth termination, and try to close today's program. So every building need a lightning protection need an earth termination system. There are four type of or two type of earth termination or earth electrodes mentioned. Type A, Type B. Type A can be vertical or horizontal earth electrode. Basically, this is an earth electrode which is isolated from the building, which is away from the building, either a vertical rod or a horizontal conductor. Type B consists of a ring earth electrode or a foundation mesh earth electrode. We will discuss it in detail on a later presentation. Now we are almost 12:30. We will be having some questions and try to answer the question and try to close the webinar. Now, the earth termination system, what is important for you is for residential small buildings without much electronics, type A earthing can be used. That means vertical rods can be used, whereas for larger buildings, also for critical buildings with a lot of electronics, type B earthing is mandatory. Means industrial building, you are supposed to have type B earthing. We will discuss about type B earthing probably in our next webinars. So with this, let me try to stop the presentation. Probably we can have the question and answer session now.
Yeah.
So thank you very much.
Thanks,
you. Participants.
Yeah. Thank you, sir. You can, people who are, I think, can you put up your screen, sir, the last slide with your contact number and email, because there are a lot of in chat box, I can say, a lot of people want to contact you for some more advice. some wanted some solutions. How do we conduct surveys? So, what is the best solution? How do we design? Many people are asking. I got a very good feedback. It was one of the best, excellent presentation that they have seen in recent time. So, a lot of appreciation I can see in the chat box. Wonderful, thank you. So, what I'll do is I will take question from the last one, so that a lot of people are asking basic questions. So I'll take the questions from now. Gopinath Purushothaman, can you share French reference once again? So there are people asking French reference.
One moment. What is the exact question? I didn't.
Can you share the French reference?
French code.
French
One
code.
moment. I don't know whether I can share it here itself. If I wanted to share, what do I do? On the chat, I think we cannot share it online.
Online, in the share you can chat. You can share.
Okay, one moment. Let me try to find out the.
You can just drop there. Yeah. So this I will dismiss. So the next question is, what are the innovative solutions for over distribution line lightning protection?
Sir, one moment, please. I am just trying to find out.
Okay, sir, no problem. Take your time.
The French code, if I get it, it would be actually a good information to the participants.
Okay.
I could get a link where the 1995 version, but that will not work out. Okay, probably I can send it later. I have the file with me, but the problem is, it is too big, and I don't know how to share in the chat or in the.
We will share it with the gentlemen who were asking, so we have a record. Probably we can. Only the code reference number. Gopinath is asking. Please tell the reference number.
Okay, NFC 17102.
Gopinath, hope you have made a record of that.
Okay, so now the next question.
Okay, so next question I'll take. Go to Prince Kumar. Which software to be used for LPS risk assessment for our facility?
Oh, there are so many available in the internet, but what we are using is in CAPE. We have designed. We have our own software. Generally, the software is not. We are not. We are using it only for our designs. We are not. It's not a free license for outsiders. So in the internet, you can find out so many softwares. Okay,
moving to Krishna Chavan. I'm going from the bottom, sir. The question: in global earthing system, can we use MS strip for IT building of 40 meters height? If yes, what will be the minimum size of the strip?
Of course, you cannot use MS strip everywhere. If you are using MS strip, it has to be restricted to some places. But in general, you can use it. But if you look at all the purposes of global earthing system, if you use MS strip, the results you may not be able to get a good result, or getting good result will be very difficult because due to the resistance of the conductor, getting values such as 1 or 2 micro ohm per meter is not possible. Sometimes global earthing system, if you are looking for a data center kind of an application like IT building, then very small values are required. With MS will be very difficult. Better you use copper or copper bonded steel material. So over to you, sir. The next question.
Srijit, what should be the size of dome conductor? Is it depends on the height of the building or size of the installation?
Mr. Srijit, sorry, it is there on the standard. Today we didn't cover it much due to time. We will have a a third version of the webinar probably after a few weeks, because next week we are going to have the webinar on a panel discussion on the CE regulation next Saturday, the same time. And the week after, we will have a selection of protective device such as MCBs, the criteria to be followed to select the device and the wires. Probably in a month, we will have the third version where we will explain all these subjects.
So Pritham Roy is asking, can we use lightning protection earthing with electrical earthing in the same grid?
Of course, yes. If you don't use it, you are violating the technical requirements and you will not achieve safety.
Oh, Kiran Kanti, for provision of a robust building protection system in a 10-story building, whether the Indian standard is to be followed or national building code.
Mr. Panda, both the Indian standard, National Building Code is also an Indian standard. The IEC 62305 and National Building Code explains the same subject. So there is not a conflict in between. Both are same. Either you can use IEC 62305 or you can use NBC 2016.
Okay, Himanshu, sir, as we are using AI conductor grid in terrace, connect to lightning arrestor and below ground building surrounding GI earth mesh. Then after connect to earth pits. So how many earth pit is required for buildings LPS?
Mr. Himanshu, we will discuss it, as I explained, we will discuss it in the next webinar. It is not like how many earth pits, but it is a little bit different. We have to make, if you are talking about a larger building, we are supposed to make a ring earthing. We will explain it in the next webinar. Thank you.
So Subrat Kumar Bera is asking, in LPG plant, the vapor compressor SRV flare take out approximately 1.5 meters height from the shed. There is a possibility to ignite in case of lightning and development of static charge. Is dedicated earthpit is required to dissipate the static charges, including installation of strip is required.
Mr. Bera, nowhere this dedicated earth pit is recommended. Unfortunately, except the OISD standard, which is a mistake. Whatever written in, because you are talking about the LPG plant, probably I think your application is the explosive areas. The recommendation in OISD standard is a mistake. They have written somewhere separate earth pit for lightning protection 7 ohm, then for neutral 1 ohm, IT system 1 ohm, something 4 ohm. That is absolutely mistake. The only best method is to make a very good equipotential bonding, including lightning protection, including static charge. Somebody is asking the neutral, of course, including neutral. And you have to make a proper TNS system if you connect your neutral as well in the same network. So now the vapor is 1.5 meter above the particular building. You have to ensure that the lightning point of strike is at least a little bit more than, let's say, for example, 2 or 2.5 meter away from the roof of the shed. Imagine you are making a rod of, let's say, 3 meters. So then the lightning is striking 3 meters away from the roof of the building, and that kind of a protection is required.
So moving to Samrat Keshari, what are the innovative solutions for over distribution line lightning protection?
Innovative solution for over distribution of line light. I'm sorry, I didn't get the question. I think
what are the innovative solutions for over distribution line lightning protection?
Okay, probably he is asking about the lightning protection of the transmission distribution lines. Of course, there is no innovative solution. There is only one scientific solution. The scientific solution is to have a conductor above the current carrying conductors, which is protecting a direct flash onto the current carrying conductors, which is avoiding the flashovers at various points, then you need to have surge arresters at different places. So there is not, I don't think that there is some new innovations came. The conductors are the same. The surge arresters, zinc oxide varistor surge arresters, or gapped surge arrestor or gapless surge arrestor, these are the same. Thank you.
Mohan is asking which LA is advisable to replace ESC and CSC.
Okay, there is not a LA to be replaced. You have to make a proper LPS. LPS, LA is a part of the whole LPS. So you have to have sometime a mesh. It actually, the answer depends on what kind of building are we talking about.
Okay. Srijit, what type of system is mostly used in, okay, that, no, we are not, that's this. What type of system is mostly used in Indian condition, early streamer or Faraday's cage method?
So we say early streamer is a non-standard and illegal system in India at the moment. Faraday's cage is the correct method.
Balchandra, which type of insulator has to be used for down conductor for boiler chimney?
If the boiler chimney is metallic, you don't need any insulator. You can directly connect the chimney, the down conductor and the metal parts of the chimney. If the chimney is RCC, of course, it is recommended you can make a small insulator. The insulator is not to avoid spark over, but to avoid corrosion in the down conductor. Probably 1 inch, 2 inch, 25 mm, 250 mm would be good.
So there's one question from the chat. I would like to take it up because it's talk about refinery and petrochemical. Manish Kumar is asking from the chat. In hazardous areas like refinery and petrochemicals, even after doing the risk assessment and arriving at LPS 4, do you recommend, or is there any recommendation where IS or IEC 62305 part 2 that minimum LPS 2 is to be ensured for such hazardous area environment?
I don't understand the question. If in
Manish Kumar, the last chat.
Yeah, normally in a petrochemical or refinery kind of application, LPL4 may not be correct. I think what is recommended in the National Building Code is, let me have a look at it. One moment. I'm just looking at the National Building Code. So what is recommended in NBC is low-rise hospital X zones in the industry and chemical. So LPL2 is recommended in the National Building Code. Probably for these explosive areas, LPL4 may not be the correct one. But again, you have to make a risk assessment. If the risk assessment says LPL4, then you can go for it. But normally for explosive areas, LPL4 may not be the correct one.
So Ramakant, who's a regular attendee, is asking, testing method of such protection device. Are we doing this? Are we doing the next webinar? Testing method of surge protection device.
I don't know whether the question is about SPD testing in a laboratory or SPD testing at the site where it is already installed. SPD's testing in a laboratory, anyhow, we are not going to discuss because this is IEC 61643 part 11, which is actually required only for the SPD manufacturer. It is not necessary for a user to understand how the testing is made. SPD testing at the site, for example, yes, of course, we can demonstrate if it is required.
Okay, so again, Raghunath is asking how many LA required for 45-meter height chimney?
This cannot be answered simply. We need to look at the drawing. We need to look at the diameter of the chimney. We need to find out. We have to work it out and tell you. Nothing like one chimney, one rod.
Okay. Sundar Pandian is asking, can't government take action against companies who produce or sell non-standard lightning arrestor?
Okay. Actually, Mr. Sundarabandin, I really don't know. But the only thing is, in case of if imagine a building or an industry where a non-standard lightning ESC lightning rod is installed, and in case of any failure during lightning, the owner of the building can be put or an action against him can be made as per Electricity Act provision 146. Criminal proceedings can be made against the owner of the building. Those provisions are there. Unfortunately, so far the provision of section 146 of the Electricity Act is not applied properly. Once when the police or the electrical inspectorate or the respective authorities start applying the provision of 146, of course, people will go for the correct type of methods. Otherwise, there are provisions to penalize, but the provision for taking a case, I think it do not exist. It depends on the owner of the building to decide whatever the kind of things which he wanted to install. But only if it fails or only if it creates a trouble, then only it becomes a liability to the nation and to the people.
So Srijit is asking, what type of lightning protection is used for marine application?
Actually, I don't understand what kind of marine application he is referring to. So it should be as per IEC 62305. But if you are talking about a marina, like a ship or a boat, then there are something else. Marine application, if it is something on the shore, a building, then of course up to 62305.
Sir, I'll take Prince Kumar Singh. How to ensure our existing LA is working or not? Any testing or maintenance program to check LPS?
Of course, actually, this is a very good question, Mr. Prince Kumar. Thanks for the question. Lightning, instead of, I will not use LA, I use the word LPS. Lightning protection system require periodic testing, periodic verification, and maintenance. These are explained in IEC 62305 Part 3 at also almost at the final stage of the standard. The detailed procedure for maintenance and the detailed procedure for testing is also included. The testing consists of the physical testing with a meter, a micro ohm meter with a test current of 10 amperes. You need to check the continuity resistance of different bonding conductors, different joints, the down conductors, probably from air termination to the earth termination system. All these are included in the standard. It's not like one line, but you need to really go through each of these requirements.
Again, Prince is asking, is lightning arrestor is applicable only for high-rise building as per the new CA regulation?
No, the high-rise building, the definition of high-rise building or multi-storied, the regulation 38, it says any building more than 15 meters or buildings such as airports, hospitals, hotels, explosive areas, commercial buildings, that means almost all the commercial buildings irrespective of height. So technically, residential buildings more than 15 meters height and all other buildings, irrespective of height, lightning protection is required. That is what is written.
Okay. Manoj Kumar Sharma, apart from building protectio, how to protect building protection must be how to protect plant structure, tank and other equipment from lightning.
So all these are structures. The structure in the sense, 62305 Part 3 talks about lightning protection of a structure, which consists of a building. It can be a tank or it can be a metallic structure, whatever. So all these are covered.
Indrajit is asking, what should be the minimum distance between down conductor if you are planning more number of down conductor as specified in this standard?
Now, there is a calculation given in the standard. We have to really calculate it and keep the down conductor away. Probably it is in some case 1 meter, maybe in another case it is maybe half meter. So it depends. We cannot make a thumb rule in this case.
Manoj is on how to protect ethanol filled storage tank from lightning.
Very simple. You have to have a lightning protection system.
Venkatesh, what is the distance between trees and buildings required?
What is the distance between trees and buildings required?
Building.
Nothing like that. If the tree is closer, of course, and if the tree is taller than the building, then of course the lightning may hit the tree rather than the building, and probably side flashes may occur. But there are some techniques to avoid.
Mm-hmm. Same thing is asking, is observed a lot of trees are planted near the house. It leads to lightning. Is asking, does it lead to lightning? Because trees are.
Yes. Any taller object, the chance of hitting is more. So if you have a tall tree near to your building, of course, the chance of lightning hitting that area is more.
So probably coconut trees are taller than the house there. Sundar Panijage asking, do we have lightning or thunder statistic in our country?
Yes, of course. Yes, of course. You can find out in the National Building Code, there is an annexure.
So Pradeep is asking how negative lightning happens as we are grounding LA, then how it possible for NLA?
We don't know what is NLA. Negative lightning is happening once when the cloud is negatively charged. So if the cloud is positively charged, then we call it as positive lightning. It depends on the charge of the cloud. Cloud can be either negative or in some cases positive. So this is not decided by the lightning arrestor or lightning protection system. This is decided by the cloud, depending upon the charge of the cloud.
So Kiran suggesting, can we have a detailed discussion on lightning protection system for magazine where explosive and detonator are stored in the next webinar? So for explosive areas, lightning protection.
That will be, we can try to make it, but only we can discuss some generic things. If you look at for a specific building, then we have to really make a proper answer. Making a generic statement during a webinar may derail the whole installation. Please don't do it. You approach a lightning protection expert, or you can send me the drawings. We will go through it properly and answer you properly.
So Saravana Kumar is asking, which type is best lightning arrestor for industries?
An lightning protection system based on IEC 62305 or National Building Code. Nothing like a lightning arrestor. People still have idea or thinking that lightning arrestor, a rod with a lot of phenyls is a lightning arrestor, a simple rod is another type of lightning arrestor, ESC is another lightning arrestor, something like that. It's nothing like that. All these rods offer certain angle of protection, irrespective of its shape. So we have to consider the protection angle in this particular case.
So Satish MR is asking, in IEC 61400-24 for LPL winter condition, especially in Japan region, only hint given is 600. How to get other parameters or consider other parameters for design LPL winter conditions?
Mr. Satish, the 61400 part 24 is talking about specifically for wind turbines. It is not applicable for normal buildings. So you have to really refer to what exactly your requirement, because wind turbines are not like a normal building. These are sometimes tall structures, isolated locations, and the climatic conditions are also different. So they have a totally, also the electronics is very critical. The blade is very critical. So they need totally a different methodology, not like what is explained in the IEC 62305. Please don't refer IEC 62305 for wind turbine. 6140024 is talking about wind turbines.
Sir, Balu is asking, is early streamer type LPS acceptable? It has less down conductor.
Oh. Balu, Mr. Balu, unfortunately, ESC is banned in India. You are using an illegal system. And this less down conductor is a story by the supplier. Nowhere in the ESC standard it is asking to put one down conductor. This is only in the printed catalog of the manufacturer. You ask the manufacturer, you download the respective French standard and you show them the figure where multiple down conductors are written very clearly. So it is nothing like less down conductor and ESC. Both are illegal, unfortunately.
So the anonymous attendee is asking, what are the standard height for air terminal?
My God, sir, it depends on what you wanted to protect. So now, Dominic, sir, can we finally close the program? Because we have about 150 participants, but.
Yeah, there are 10 more, but I picked up from the down because most of the answers would have been in your presentation for the early question that is posted must have been answered in your presentation. So for the reason I took it from that, I think we have answered over 32 questions. 45 questions we answered. As we say, learning is never ending. Okay, every session that Mr. Gopakumar does is a lot more new, new learning or new ideas is coming up. But what he does is he follows strictly all the IEC code or NEC code. And we continue our journey in reaching out to every electrical engineers on best practices. So next one, what we're talking about, DISCOM, distribution, responsibility of DISCOM to the premises, that is consumer premises. This will be next Saturday, same time at 11 o'clock. My colleague Lakshmi and Navya would have probably given you the link there. And this recording of the whole session also will be made available to you through email. And you can again go back and probably refer. But those who want to contact our speaker, then the email ID is already mentioned in the chat box and his contact number. They will be happy to assist you further. So nice. We almost 2 hours of this webinar. It's quite long. And I wanted to thank those who are patiently waiting. Still there are good number of participants waiting to hear what we want to talk next. So thank you. You all have a great weekend with family and stay safe. We will come back and see you again next week, Saturday at 11 o'clock. I want to thank Lakshmi and Navya, who are my colleagues at the back end, for supporting this. Thank you very much. All the best. Thank you. Bye-bye.